Assalamualaikum and good day everybody. Dear student, thank you for attending our synchronized class. As you know, during online class, we have completed chapter 1 and half of the section of the chapter 2. You already know how to use OrCAD and how to do the simulation. For today's video, I would like to show again the exercise that we already did in the class. I hope this will help students that still have problem to design the circuit schematic and to simulate the schematic. By the way, if you still have problem, please refer to the lecture notes. In the lecture notes, it's already written down every step and the guidelines. For this example, we'll be using a simple DC series circuit as shown in figure 2.8. In this example, you are needed to determine the voltage potential at node A and the total current for this circuit. By using Ohm's law, it's clearly we can get the voltage at node A is 50 volt and the current is 0.5 ampere. Instead of using the theoretical calculation, you will use PSpice to determine and validate the calculated values. Let's do this example again like you did in the class. Circuit diagram can be drawn using Capture or Capture CIS. CIS stands for Component Information System. To start the Capture program, you may navigate to OrCAD and Capture. Click the Capture.execution application file. Before the circuit diagram is drawn, the project type and corresponding library need to be set up. From the top menu, click File, New Project. To create a new project, new design created in Capture will automatically create a project file.opj, which contain schematic, libraries, and output file. In the new project window, you need to choose the project type and name the project and set the location path for your project. By the way, there are 4 choices that can be chosen for your design: analog, PC board reset schematic as discussed in the class today. In this example, I put the name is a DC series circuit. For PSpice purpose, you need to always choose analog or mixed AD to start your project, and this also will automatically activate a new PSpice menu in the top menu. Okay, you are strongly advised to create an individual folder for each new project in this OrCAD Capture to avoid any difficulties later. And then you click OK. The next window to appear is a Create PSpice project, which set up the project for PSpice simulation. There are 2 choices in this window, but if you start from scratch, you need to choose Create a blank project. After you click OK, you will see interface with schematic page, complete icons, tool palettes, and also top menu with a PSpice menu activated. Generally, after the first interface is successfully created, the next step are to place components, connect components, label wires, and run the circuit to perform PSpice analysis. To simplify all the general steps, as I mentioned earlier, we will use a simple DC series as shown in figure 2.8 in your notes. The first step that you need to perform is placing all the components in the workspace. However, there are the points that you need to be very careful when placing the components. Always use part symbol from PSpice library. Always search and select the correct symbol for your component. Always set the correct value and gain for your component. Always observe the polarity of your component. And always include 0 ground for your reference point. In this example in figure 2.8, the part name is VDC for DC voltage supply and R for the resistor. To place the component, you can click Place Part from the top menu, or you can click the Place Part icon as shown here, or you can use the press P from your keyboard for the shortcut. Then you need to make sure you add the PSpice library to the place part. To add library, click the add library, and you can use Ctrl A to select all the libraries. The libraries from the PSpice subfolder. Ctrl A and open. Then after that, you press OK. After finish adding library, you can start drawing your circuit by placing all the needed component in the workspace. Type input VDC. You can use lowercase or uppercase in the part box, and you press OK. Click, left click, and right click to end mode, or you can use escape. This is the zoom button that you can zoom it. Then we add the resistor R. Okay, so you have two, right click and mode or escape. Then always remember to include the 0 ground for PSpice circuit. Click place ground, or you can use the icon here, ground. Choose it, and you change the name to 0. Okay. After you place the components, now is to assign the component value based on your example. Double click on the components. Change the value of the resistor to 100 ohm. Another way what you can do is just clicking this, you change to 100 ohm and change the voltage to 100 ohm. After all components are completely labeled, the next step is connecting components using wire. The circuit that need to be analyzed must be in the closed loop. You can connect all components using place wire, or you can shift plus W, or you can use the icon here and start do a wiring. And wire. You can adjust this wire to make it better. One of the most important steps that is the troubleshooting process during error and warning is assigning the net alias to the circuit branches. Okay, by default, Capture will assign random name for all connection in the PSpice circuit, and which make it harder to isolate the error connection if you have a large number of branches. By using the net alias means you tag or label each branch with your own branch name. So in the example, I'm using plus VDC, net 1 and ground. How you want to place the net alias? Click place, choose net alias, or you can use the icon here and 1 or shift N, net alias, and write plus VDC. Press OK. Put here and escape. Do it one more time. Net 1. Okay. In here. Escape. 1 ground. Okay. The final step before you simulate your circuit is to place the probe marker to the node which you want to analyze. To place the marker, click PSpice marker, or you can use the marker tool palette here and click the desired probe to be attached in the drawn circuit. PSpice marker. There are 4 different markers that can be selected as mentioned in the class. You have voltage level, voltage differential marker, current marker, power dissipation. Now, let's place the probe markers. From example, you need to determine the voltage at node A and the total current for the circuit. This is the tip to make sure your probe marker can be placed. Click on this wire, take voltage and put it here, escape, current and place it here, escape. Then you can rotate this if you want it to be exactly same in the example. After the circuit is completely drawn and saved, the specification for the analysis need to be given in order to simulate it. This specification control the simulation and display of the output variable. A simulation profiles need to be created first before all the specification can be input. To set a new simulation profile, click PSpice, New Simulation Profile, or you can click icon from the tool palette. PSpice, New Simulation Profile, name, type DC series as the profile name, and click create. And the next window will appear is a simulation setting. Look at the browser down here, okay, if you couldn't find your simulation setting. Here you are using time domain analysis. There are 4 types can be selected as mentioned in the class. So for this example, we are using time domain, and the run to time is 1000 nanosecond, and the option is general setting. This is the best analysis that you can choose to analyze this DC simple series circuit. Then you press OK. The next step or final step is to run the PSpice analysis. Click PSpice, run, or click run icon, or you may hit F11 for the shortcut. So it's running and it's completed. The next window to appear is the probe window, displaying the simulated waveform as shown in figure 2.7 in your notes. So the output file will be automatically named with the profile name, which is DC series.tat. Alright, so I think we've been covered in the class how to play around with this wire if you want to make it bigger or you want to change the color. So that is only example that I would like to show to those that still have problem to simulate. If you follow the step in the notes and also in this video, you will not face any error in the simulation. Alright student, thank you. See you again.